Hey Becca, what are we learning today?
Today, we're going to learn about the sum and difference angle formulas. The sum and difference formulas tell us what the sine and cosine of two angles added or subtracted together will equal. They have their own formulas because there are certain scenarios where we know the sine and cosine of each individual component, but we don't know the sine or cosine of the sum. The sum and difference formula for sine is sine A cosine B plus or minus cosine A sine B. And to remember this, you just have to think to yourself, sine, cosine, cosine, sine. SCCS. And you leave the angles as AB, AB. They don't change. Notice that this plus or minus here is the same plus or minus here. So if this is sine of A plus B, then there will be a plus sign in between these two terms. And if this is the sine of A minus B, then this will be a minus sign. So the sign is exactly the same. You can think same sign because they both start with S. Cosine of A plus or minus B is equal to cosine A cosine B minus plus sine A sine B. So notice the angles stay in the same spot again, AB, AB, but our pattern here is cosine A, cosine B, sine A, sine B. So for cosine, it's cosine, cosine, sine, sine. Also notice that the sine, if it's positive for cosine, it's negative in the formula, and if it's a minus sign here, then it's positive in the formula. So for cosine, it's the opposite sign, and for sine, it's the same sign. So let's go through an example with an angle that we know, sine of 60. But instead, I'm going to break that down into sine of 30 plus 30. And we're going to use the sum formula for sine of 30 plus 30. Now we know that the sine of 60 equals the square root of 3 over 2, and we know that from our unit circle. But now we're going to use the sum formula to see if we get the same answer. So sine of A plus B equals sine of A, 30, cosine of B, which is also 30. We have a plus sign and it's the same. Cosine A, sine B. Sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. Cosine of 30 again, square root of 3 over 2. Sine of 30, 1/2. Combine these two terms, multiplication. We've got square root of 3 over 4 plus square root of 3 over 4 equals 2 square roots of 3 over 4, and that reduces to the square root of 3 over 2. So we verified the sum formula for the sine of 60 degrees. Now we're going to try an example of an angle that we don't necessarily know the answer to. Cosine of 75 is not on the unit circle, but we could break 75 up into two numbers that sum to equal 75. And the numbers I'm going to use are 45 plus 30. 45 and 30 equal 75, and we know the cosine and the sine of both of these numbers. So we can use that in order to find the cosine of 75. So this is our A and this is our B. So using the formula, we've got cosine of A, cosine of B, opposite sine, minus sine of A, sine of B. So now we can solve this using our values on the unit circle. Cosine of 45, square root of 2 over 2. Cosine of 30, square root of 3 over 2. Minus sine of 45, square root of 2 over 2. Sine of 30, 1/2. So if we combine these terms, multiplication, we get square root of 6, because you multiply the insides, over 4, minus square root of 2 over 4. So our answer will be square root of 6 minus square root of 2, all over 4. So this is in fact the cosine of 75. If you plug this value into a calculator, you get approximately 0.26. And then to verify, if you plug in cosine of 75 degrees into your calculator, making sure your calculator is in degree mode, you will also get about 0.26. There are certain scenarios where these problems can be done more than one way. And in these last two examples, I'm going to show you that we can break 15 degrees into multiple different sums or differences. So for sine of 15, I'm going to break 15 into the difference between 45 and 30. We know the values for sine of 45 and sine of 30, and they're going to help us find the sine of 15. So we're going to use the difference formula for sine. Sine of A, cosine of B, same sign, minus cosine of A, sine of B. So now we can use our unit circle values in order to find sine of 45 cosine 30, cosine 45 sine of 30. The sine of 45 is the square root of 2 over 2. Cosine of 30, square root of 3 over 2, minus cosine of 45, square root of 2 over 2, times sine of 30, 1/2. Combine this term, multiplication, square root of 6 over 4, minus square root of 2 over 4, and our solution, square root of 6 minus square root of 2 divided by 4. Now, when we use cosine of 15, we don't have to break it into 45 minus 30. We could also break it into 60 minus 45. Since we know the values of cosine of 60 and cosine of 45 from our unit circle, we can do this problem the exact same way, just using different values for A and B. So we're going to use the difference formula for cosine. Cosine A, cosine B, opposite sign, so it becomes a plus, sine of A, sine of B. And using our unit circle values, cosine of 60 is 1/2, cosine of 45, square root of 2 over 2, plus sine of 60, square root of 3 over 2, sine of 45, square root of 2 over 2. Combine our terms, square root of 2 over 4, plus square root of 6 over 4, and our answer, square root of 2 plus square root of 6, all over 4.
Thanks for watching my video on the sum and difference angle formulas. If you found this video helpful, give it 2 thumbs up And make sure you subscribe because we're posting new videos every Monday and Thursday. See you then!